Before we move on, if I wanted to save an image after I've edited it, the big word of caution here is use a different file name than the file that you used for the original. Otherwise, it will replace the original file and you can't get it back. Every time you do anything to an image, resizing, rotating, colorizing, anything, you will degrade the quality of the image. So you always want to keep your originals for everything. And this goes for your iPhone pictures, for your digital camera pictures, scans. The original is the best it's going to get, period. Always keep your original. Any digitized medium, yes.
What is the pillow doing in the background?
The pillow is doing all of this. The pillow is it does all, yeah, when we open that file as a pillow image object, we're actually creating a pillow type, an instance of pillow that has that image information as an attribute. And then all of those methods that we're calling crop, resize, whatever, those are part of that pillow object.
Are those images in your own directory?
The strawberry one, yes.
Okay, so
Yeah,
you can't pull that up.
you cannot pull that up.
Okay.
But what you should do is if you're downloading that pillow practice, is find an image online. Just go to Google image search, get a nice high resolution image of whatever you want to play with, download it and save it right in your Python directory. Then you can open it. I would recommend making sure the file name is nice and short. Start with a JPEG. Those are some tips, but make sure it's in that same directory. That's the important thing. So when you're saving a file, never use the same name as the original that you opened, because it'll ruin your original. And you always want to keep your original because that's the best it's going to get. So some other things that you can do, there's lots and lots of commands. These are all in that pillow practice document, but you can transpose images. Transpose allows you to flip them vertically, horizontally. And then if you can use a transpose and transverse are different directions. Basically what it does is it takes the bottom corner and swaps it with the top corner. It's like it rotates at 90 degrees and then it flips it. It's really weird. Mostly transpose and transverse are used for image analysis. One of the things that my son has worked on in his past is he actually worked on a pair of glasses that had embedded cameras in them. You're like, okay, yeah, Meta does that with Ray-Ban. No, these glasses, actually, the cameras faced your eyeballs, and they took hundreds of pictures of your eyes every day. They could diagnose up to 50 health conditions through these glasses and training AI to recognize things. What did they use to train the AI? Transpose and transverse. They increased the contrast of the images. They flipped them around. They did all kinds of analysis on them. But they use those things. Transpose and transverse are kind of weird things. Let me open a different a different file here called buildings. And then I'm going to show you some of the things we can do with this. Okay, so here is the original, and there's flip top to bottom. That's what it is. So that's the OG. Flip top to bottom, flip left, right, that's kind of understandable. But transpose is a little weird. Okay, so this one flips it and then rotates it. Like I said, there's not a lot of real practical uses for that, but it's really useful for image analysis. So transpose, transverse, that's what those do. I can also rotate an image. Now, image rotate allows you to rotate the image. You could rotate it, of course, in 90-degree increments, and it would retain its square shape. But let's say I rotate an image 45 degrees. The interesting thing about images is that they're always going to be a square, no matter what you do. So if I rotate it 45 degrees, it still has to be a square. If I just rotate it using image.rotate to give it 45 degrees, it'll rotate 45 degrees like this, And the parts that don't fit in the original square, because I rotated it 45 degrees, just get cut off. If I give it expand equals true as a second argument, then it will expand the size of the image so that it can contain those corners. But the size of the image actually changes. So you have to decide. If you're going to rotate it something other than a 90-degree increment, do you want to keep the corners and change the size of the image, or do you want to keep the size of the image and lose the corners? That's the choice. There's no in between there. You can, by the way, decide what the background color is. That's another argument. So rotate. I'll just show you that one with my buildings here. So there it is, losing the corners, same size. And then if I say expand equals true, changes the size of the image, keeps the corners. Okay, so that is rotate. We've also got a number of filters. Now, notice I'm importing image and image filter. Okay, if I want to use filters, I have to add filter. And these are way more basic filters than what you think of as a filter, right? When you think of a filter, you're thinking of a complex set of filters. But I've got the first set of filters is around blurring. I've got three different choices here with blur. I've got image filter.blur, I've got image filter.box blur, and I've got image filter.Gaussian blur. There's a difference between them, and I'll show it to you right now. So here is what blur looks like. Can you see the difference? Barely, right? It just makes it a little bit more blurry. Sort of like if you wear glasses and you took them off and you have a minor prescription. Box blur takes an argument, you can see here, that determines the strength of the blur. So blur is just a little bit or nothing. That's the choice. Box blur gives you an option. So when I run box blur with 5, a little bit blurry. If I run box blur with 30, very blurry, right? But looking at this image, do you notice anything that's interesting about how it looks after it's been blurred? Anybody sort of seeing like a plaid pattern here? Yeah, that's right. They should just call it astigmatism. And what level would you like? Um, you're seeing the plaid here because the mathematical formula for that blur, as indicated by the name, is a box. So it uses a square shape to blur the image, which in an image like this results in some weird kind of artifacts, some things that shouldn't be there because it's not really that way. So I'm going to leave that one open because I want to use it for comparison here in a minute. But I want to skip to Gaussian blur. Gaussian blur is sort of the gold standard for blurring images. It's going to be like looking through an image through frosted glass, which is exactly the kind of, unless you want that box effect, it's really what you want. So there is Gaussian blur. So now original box blur looks like this, and Gaussian blur. See the difference? It's nice and smooth. Most of the time when I'm blurring something, I use Gaussian blur because it allows me to adjust the level by giving it an argument. Plus, it's very smooth. If I want that box blur effect, though, it's sitting there for me. So I've also got a few other filters that are fun to play with, and these are just a few. You can look up the others. I know you all know how to use Google here. I've got the emboss filter. Okay, so it looks like it's embossed on paper. And what it does here is it finds areas of high contrast in the image, and it uses those edges to produce that embossed look with a lighting angle. Kind of a cool effect. Also really useful for identifying objects in images because it finds those edges. Okay, so we've got emboss. We can just find edges here. This just finds those areas of high contrast and accentuates them. Okay, so again, for finding objects in images, if you're doing analysis, kind of a cool creepy effect though, if you want to use that. And then edge enhance accentuates the edges of the pieces in the image just by amping up the contrast a little bit. So it makes it look kind of grainy, but it actually, if you run find edges after that, you'll get a different effect. So that's useful for that also. And one final thing that we can do here is you can convert. If I use image.convert, I can convert it from RGB to L. I don't know, maybe levels is what it stands for, but it's going to give you a grayscale image, not black and white. A true black and white image is where every pixel is either black or white. If you want an image that doesn't have colors in it, it's called a grayscale image, which is L. And what that means is we just get one channel, not RGB, just L, which says how light or dark is each pixel. But looks nice. Okay, so those are other ones. I've got some other things down here in the second part of this file that you can play around with that we're going to get into next session because we're running close to the end of time here. I'm not going to go into that piece yet, but we'll play with those next time. You're welcome to play around with any of that, of course. And some of the things you might want to try just leading up to this, there is no sandbox for this module, just an assignment. But you might want to play around with listing files in a directory, os.list directory. You give it a path. If you put a single period in quotes inside that, it will use the current directory. But you can use that to list the images in a directory. Try figuring out how you can use user input to load an image or to open an image file. That's useful for the project. You might want to try different options for functions or creating functions for different things you could do to an image, like a function that takes an image as a parameter and returns an image that's converted to black and white, let's just say. So you could use that function over and over and over. You could use saving an edited image using user input name. And just think about like how if you were creating a command line image editing program, how would that work? What would that workflow look like? What kinds of questions would you ask the user? How would it work? Because that's kind of what we're building toward here is a program that allows the user to edit images.